Now it is not silent anymore. It's actually recording. All right. So you guys can remind me to press the enter key because I usually type the whole command to do the recording, and then I wait until the right time to start the lecture. By the time I start the lecture, I would have forgotten to press the enter key. Alrighty. So now it's now there's voice, and you will find out when you watch the video. There's a whole bunch of silence at the beginning.
I'm going to remind you every day. Oh, I'm going to remind you every day.
Well, I mean, it's only if you value this extra resource.
I will remind you every day.
You remind him to remind me every day. Yeah, I like the daisy chain concept. All right, moving on. This is also new. This is added because of accreditation. Okay, because in accreditation they're looking for regular effective contact. It doesn't really apply that much to face-to-face classes. In order for me not to have regular effective contact with you with a full face-to-face class, I will have to try very hard. Okay. In other words, you raise your hand, and just have a facial expression and say, "I got a question to ask you," and I will have to basically stare at the ceiling and ignore you the whole time. Okay. Then I won't be having regular effective contact. If I even try to address your question, like if you raise your hand, I go, "Okay, go ahead and ask the question," I am having regular effective contact with a full face-to-face class. So this section is mostly applicable to hybrid and fully online classes where the professor really cannot see you, and unless something is done, there's no actual effective contact. But with a full face-to-face class like this one, it should not be an issue. Okay, but I'm just going to go through this. You can find me using my office hours. My office is kind of cramped, but I will try my best to answer your question. Okay, you can bring your laptop computer. We'll set it up somewhere, and I'll take a look at your computer in case you have something to show me and go like, "Oh, well, this is not working. Can you show me why? Tell me why it's not working." Lab time. This is actually quite important for this class. The lab time is right after the lecture. It starts at 10:30 until about noontime. It's not in this classroom. It's going to be in room 128, which is a lab classroom. That would be a perfect time for you guys to work on your homework assignment or to practice something that I showed you during class. Okay, but because of the timing of the lab time right after the lecture, most of the time I'm going to upload my video recording during the lab time as the first thing that I do. So maybe 10 minutes into the lab time, the video will be online. So you can actually review the lecture and actually do some of the things that I did in class, and try to practice it, during lab time. So this is a really important part of this class. The lab time is important. Office hour online, okay, if you cannot make it to my office, but you can still contact me, using online means during that time. I don't really use forums for this class because it's fully face-to-face, so kind of forget about forums for this class. Messaging will still work within Moodle. If you want to use that particular way to talk to me or communicate with me, that's okay. But I have to warn you, messaging within Moodle does not allow you to put pictures into the communication. So you can't really take a screenshot or copy and paste text from the text window when you're writing programs. So it's okay, but it's kind of limiting in terms of what you can do as far as communication is concerned. Email and phone, that works fine for this class as well. So go ahead and email me using the email address from earlier. Phone doesn't really work too well with me. You can leave a message, and but I think for the most part with programming classes, email works better because you can actually type up or include an attachment of the source code or a screenshot of something. So that works out better. Time frame policy basically just mentions how often am I going to check my email, and what is the expected turnaround time. From Monday to Friday, it's once a day, so the turnaround time is about 24 hours. And over the weekend, it can be up to 48 hours because I only check email once per weekend. Okay. Are there any questions? questions? Okay. All right. Moving on to etiquette policy, which does not really apply to a face-to-face class as much, but basically, things that can be interpreted as harassment or discrimination is not going to be tolerated. Okay. So that would include racial slur, sexually suggested words, personal attacks, and stuff like that. Cyberbullying is bullying, and that won't be tolerated as well. And you can see some of these are hyperlinks. So if you click on the hyperlink, it will bring you to an explanation of what is cyberbullying. Okay. Spamming is interesting because spamming is a form of denial of service. Because somebody's going to fill up my entire screen with all the spam messages, and all the other actual legitimate, stuff that I need to read, will be scrolled off. Okay, so that's actually a form of denial of service. Content that can be interpreted offensive is also not going to be tolerated. That includes cursing, name calling, and so on. Alrighty, so moving on. First day of class. Okay, absence on the first day of class is a reason to be dropped. So that means everybody here, physically here, is not going to have this problem. On the other hand, if someone is watching this video because that person missed the first day of class, that person, will be dropped from the class. I can add that person back to the class if there's room, but that person will be dropped first. Okay, but you guys don't have anything to worry about because you're here. So I'm going to pass the roll sheet right now, because I think anyone who's going to be here is here already. Accommodations. This is also new. I was requested to put a section about accommodations. It basically talks about if you have any type of accommodation need, you will have to kind of contact the DSPS office so that they can arrange that. Okay. And if it is something that need my cooperation, you might want to bring it up with me as well, okay? So that I can, help make that happen. Moving on, excessive absence. Oh, well, this is actually pretty easy. Excessive absence is 6% or more absences. That's it, okay? We meet twice a week, and this is a 16-week semester. So that means, basically the third unexcused absence is excessive, okay? You can be absent twice throughout the entire semester for no apparent reason, okay? They don't have to be excused, but the third one is going to be excessive. So I use my roll sheet to kind of keep track of attendance, and if I spot anyone, with 2 absences, I would usually kind of highlight it, just so that that person will notice. Okay, you got 2 already. The next one is going to be excessive. But that's basically the bottom line of this one. Because this class is face-to-face, I will only use taking roll as a method to keep track of attendance. All right, so you click understand here. Excused absences. Certain absences are excused. They're required to be excused for health reasons. If you have a sickness and you have to be absent, because you don't want to infect the whole class, or you're not fit to go to a class, you can get excused absences for that, but I will need to have a note from a doctor or the nurse office in order to have it excused. All right. The other 2 are excused as well. Military and jury duty are also excused, but once again, you need to show me paperwork so that I know okay, this is the reason to be excused. Somebody asked me, what about funerals? Well, technically speaking, unless it is a funeral of self, it won't be excused. But I think if it's a funeral of self, there are other concerns about, getting a good grade out of the class. So funerals, unfortunately, are not excused. So that's going to be a part of the unexcused absences. Are there any other questions? Now, what if it's a funeral, and then there are other things to take care of, afterwards, and that's going to take time away from, attending classes and whatnot. There are options, okay? There's such a thing called a incomplete grade, okay? So for people who really have just too much going on and cannot really, go to classes, that those people need to look into incomplete grades. All right, late policy, that's a simple one. There's no late submission. Okay, if something is due usually the due date is right before the class starts, which is 9 a.m. So 9:01 is late. Okay, so the policy is there's no late submission. Turn everything in on time. Academic dishonesty. Okay, so I'm trying to use a more positive way to look at things. So we'll talk about academic integrity instead. The grade of a particular assessment of a particular student reflects the academic performance of the student and only of the student who turned in the assignment or the assessment, the piece of assessment. So that means it should not be reflecting the academic performance of somebody else. Okay? Now, how do I know whether it's reflecting the academic performance of that particular person? I'm looking for consistency, okay? So I'm looking at the score of homework assignments, and then look at the score of the tests. If there's a big discrepancy, well, that means, I need to look into it, okay? When I look into it, sometimes I will spot, actual hard evidence of, hey, how come these two programs are identical or close to identical, or I can actually see, the artificial editing that is introduced to make the programs look different. Okay, there are some programs in this class where the entire class will turn in 2 or 3 variations because those programs are kind of the degree of freedom is really limited. But later on in the semester, the homework assignments are going to be more difficult. It's very unlikely that 2 people will turn in something exactly the same or even similar. This one is kind of funny. At the time of the assessment, not after the assessment. Okay. It has to be following all the rules of the assessment, as well as general rules already discussed in the syllabus. That means if I say this is going to be a closed book exam, then it's going to be closed book. Okay, the book is not going to be a resource. We'll talk about that a little bit later. Using only the resources that are permitted by the instructor. Okay. If you want to use a resource that is not permitted explicitly by the instructor, me, you might want to ask before the assessment. Okay, we're talking about exams here. So for instance, if I just say it's open book, open notes, okay, and you have a resource, maybe it's a chart or something like that, and you say, okay, I might want to bring that in. Well, if you're not sure, just go ahead and ask me. Okay. All right, so click yes, I understand. Student rights and responsibilities. This one is really just for your education, because as a student in the Los Rios district, this document is actually, reading this document is to your benefit because you will understand your rights as well as your responsibilities. Okay, what if you're wrongfully accused? What is the process to file a grievance? Okay, so you might want to understand, what you're entitled to as a student of this campus. So that document, it can be useful. Classroom behavior. The one thing that gets me, or that upsets me the most, is disruptive behavior that stops other students from learning. Okay, that's the one single thing that upsets me. If someone falls asleep in the classroom, that doesn't bother me as long as there's no major snoring. Okay. When I was a student, I used to sleep a lot in my classes. And there was one time I was being very disruptive, when I was sleeping. It wasn't the dozing off part that was disruptive. It was how I woke up that was disruptive. Okay, just imagine you're in rave hall. Okay, rave hall is an auditorium, right? So we have, tiered, desks. So I was dozing off at the back row, and just dozing off, and then something startled me, and I woke up. But I didn't just wake up and go like, oh, I see, I just missed half an hour of the lecture. I woke up, startled, so I did this, like that. And remember, it's an auditorium. It's not just like a flat classroom. So my pens and notebook and stuff like that, got thrown down maybe 3 aisles or so. So that was slightly disruptive and entertaining to other people as well. You have no idea, under what kind of circumstances I can fall asleep. I was in my bosses, which turns out to be the owner of the company, one time, and there were just the two of us, talking about something, and I fell asleep while he was talking. I think he was talking about something about, oh, we can add this feature to the C compiler and whatnot, okay? And I just fell asleep. No, he did not fire me because I was the only software engineer at the time. If he were to fire me, there wouldn't be anyone doing software work at all. So anyway, just don't be disruptive. Other stuff, I can usually just go like, that's okay. Falling asleep, it's not a problem for me. Okay, so just no disruptive action. That would include chatting. Sometimes I understand. Occasionally you want to borrow a piece of paper from your neighboring student, or you run out of lead on your pencil. That's okay. I can certainly understand that. It's the habitual type of chatting that I have a problem with. Okay. Interrupting. If you have a question, just raise your hand and I will address that question as soon as I get to a point where I can stop and answer the question. Mobile devices, you want to turn off the ringer at least during class. If you are expecting a phone call, it's important. Like you're getting an interview, okay, and you're anxious to see to answer that phone call. That's okay. You can do it outside the classroom. Just put your phone on silence mode. You see, there's an incoming call. It is important. You just kind of quietly exit the classroom, and come back in when you're done. Okay, that doesn't bother me at all. Please do not drink or eat in the classroom. This is a policy that is applicable to all classrooms and all labs. Within this classroom, I'll give you one exception. If you have just clean, plain drinking water, that's okay, because we don't have any computers in front of us, and if there's a spill, it's just plain water. It just evaporates, doesn't leave anything behind. So, that's okay. But in the lab, in room 128, we do have computers, and I don't want any drink in that classroom. If you need to drink, you just kind of walk outside, to finish the drink and then come back in. All right. Come to class on time. Walking in late can be distracting to the class, especially if someone walks in late and wants this particular seat. So that person will have to walk all the way through, and ask people to make room and then squeeze all the way into here. So that can be a little disruptive. If there is a class prior to ours, we'll want to let everybody out first from the previous class before we walk in here. It's not just etiquette, it makes sense. Because if you think about it, if the other class is here and you're trying to come in here, so 30 people try to walk out, 30 people try to walk in, and the door is only so wide, right? And I'm not going to start the class until everybody is here. So you might as well just let everybody out first, then we all come in. I think that's a better use of our time. Questions are welcome as long as they are related to class and asked in an orderly fashion. In other words, if 3 people try to ask questions at the same time, I cannot listen to all 3 questions. Okay, so that's not going to be effective. Just take turn, and I'll just kind of point out, okay, go ahead and ask a question, go ahead and ask a question, and so on. It's all common sense stuff. How to attend lectures. I'm going to leave most of this, to you to read, okay? Most lectures are recorded unless there's a technical difficulty or I forget, okay, operator error. I cannot promise every lecture will be recorded and uploaded simply because, well, things will happen. So you do want to take notes, okay? You don't want to rely 100% on the recorded lectures, okay? Bring a piece of paper, bring whatever device that you regularly use to take notes, okay? And that will be helpful. However, the other side is the most important part of a lecture is not try to copy everything that I say or everything that I do, but to understand why I'm doing it, okay? The how part is important, but not as important as the why part, okay? Because once you understand the why, you will probably be able to do a Google search and find out how to do it. But it's the why part that is important. Try to read ahead of my lectures. So if you know from Moodle, if you know that next class we're going to talk about a particular instruction, read ahead of me. You don't have to fully understand the instruction. Just read a little bit ahead of me, and that will help prepare your mind the next time we have a lecture. Okay, how to succeed in the class? There's no guarantee. Okay, this one is kind of long, so I'm not gonna, read out the entire thing. You're supposed to read through this whole thing, but I'm not gonna read the whole thing through. All programming classes, not just mine, not only this class, it's all about being able to understand the concepts and apply those concepts. Okay? In other words, if you have a thorough understanding of algorithms, programming concepts, and whatnot, and you tell your potential employer, your interviewer, and say, I understand all of this stuff. And then your interviewer says, okay, show me whether you can apply these things or not. Write me a program that can do X, Y, and Z. And you say, well, I only understand the concepts, but I cannot apply it. Okay? Well, what are your chances of getting employed as a programmer, as a software developer? Well, pretty close to zero, right? So it's about understanding and being able to apply. So now the question is, what is understanding, the material of a class? Okay. In other words, we are trying to understand what is understanding. This is meta understanding, because it is the understanding of understanding. The best way to do it is to say, okay, what is not understanding? To understand is not to read materials over and over again. Okay, I know a lot of hard-working people. Okay, I have classmates in high school who are really, really hardworking, and they will read something and then they can memorize just about anything. Okay, but that's not understanding the material. Next one. Memorizing is not understanding. Okay, it kind of goes along with the first one. And watching the YouTube videos a few times over is not understanding either. So now that I have kind of described what is not understanding, what is understanding? What do you think? Well, I'm going to skip a little bit here. Okay, so there's a little bit of example here. I'm just going to skip all the way to this nonsense. Because the best way to understand what is understanding is not understanding. Okay, so focus on this sentence here. Boja D becomes immodified when it is nut-based. Okay. What does it mean? What is the meaning of this sentence?
It means I need a thesaurus.
No, those are all completely made up words. I made sure those words do not exist. Okay? So, in other words, it is impossible to understand what this sentence is actually saying. Can you memorize this sentence?
Yes.
Yes. Can you regurgitate this sentence?
Yes.
You can even rephrase this sentence, right?
Right.
You can even ask questions about this sentence and answer it. Okay, because you can ask, what does a Boja D becomes when it is nut-faced? And the answer is, it is immodified. Okay, is that understanding?
No.
It is understanding of the mechanics of the language, the sentence structure, but it is not understanding of what the sentence is really trying to convey or to explain. Is that making any sense? Okay. Unfortunately, that's how some people study. Okay, they just read the whole sentence. They make sure they can recite the whole sentence. And then they go, okay, I'm done studying. No, not for a programming class. Okay, that might work for some other classes, but not for a programming class. To understand the sentence, there's the what. In other words, what exactly is a bourgeoisie? What is getting emolified? What is the action of nut-faced? Okay, that's the what. That's the how. Okay, the question is, how does a bourgeoisie get nut-faced? What is the mechanism? Okay, what is the process? And also sometimes there's also the why. Okay, in assembly language programming, the why is not as important as object-oriented programming. Now, in object-oriented programming, there are a lot of features in C++, right? Some of you might have taken cisp310 already. Mention a few major concepts in object-oriented programming in C++. And abstract. Go ahead.
Non-member functions.
Non-member functions, okay? So non-member function is fairly easy to define, right? Those functions are simply not a member of any class. Well, that's easy. That's the what. But why?
I don't know.
Why do we have those things? Why do we have friends in C++ programming? Why do we have abstract classes in C++? Why do we have protected as opposed to public, as opposed to private, for information hiding? The why many times, often, is more important than the how. Okay, the how is implementation, but the why is the reason why we even have those things. Okay. So in this case, for this nonsense sentence, the question is, why do we even care about bourgeoisie? What is the significance of bourgeoisie? Why do we care whether it is emolified or not? Okay, what is the significance of emolified? What is the significance of the action nut-face? Okay, those are the questions. The whys are actually deeper than the what, and the whats are deeper than the how. The how is really just the mechanics. It's like, oh, okay, this is exactly mechanically, how something is done. But the what is saying, okay, but what is it? The why is even more important. And many times in a programming class, you will probably have this question. I know that when I was in programming classes myself, I often have this question. I don't really understand this. Okay, so what do I do about it?
Ask.
Nah, that's not important. We'll just move along, right? Just skip that sentence, skip that paragraph. The worst thing you can do is to skip something that you do not understand. Okay, so you got to stop and say, okay, I'm not really quite understanding this. Ask questions. Okay, slow me down. Because I can go really fast in many of my classes. I can go warp speed. Okay, it doesn't mean that you have to say, oh, since tech is going at warp speed, I'm going to try to go at the same speed. Nope. Slow me down, okay? Sometimes if I skip a few things that I really should be mentioning, sometimes I forget, okay? You just slow me down and go like, Tag, I think you didn't mention about this and that, or you did not explain this part, or can you explain it again in another way, okay? So don't let concepts go without understanding. That really is important. Signal me as soon as you realize that you do not understand a particular concept. As I mentioned many times already just today, the how is not as important, okay? In other words, if I type a command in like 0.5 seconds and press the enter key and you didn't quite catch the command itself, it's not a big deal because it is getting recorded. You can just pause the screen or just go frame by frame, and you can see exactly what is the actual command. That's not the important part. The important part is, what does it do? Okay, why did I type that command? What is the reason that I use that particular command? Okay. formulate a question about what you do not understand. I know this doesn't sound important, but it really is. Because a vague and general statement or question is not going to be very helpful in the sense that I don't know how to answer the question. I know that there's something I need to explain again in a different way, but it doesn't tell me what it is. So I don't know what you're talking about. It's okay. It is a signal to me that something needs to be explained again, but it's not helpful from the sense that I do not know which part of the concept do I have to explain again. So it's more helpful to ask specific questions, like I don't understand what makes a Bolger bee different from a Doja bee. So Bolger bee versus a Doja bee. Okay, so I might have mentioned one before that particular nonsense sentence, and you go like, hey, hold on a second here. What is the difference between the two? Okay. Or can you explain nut phase, which is an action, in smaller steps? Okay, step 1, step 2, step 3. Okay, what does it mean to nut phase something? All right. Are there any questions? Are we understanding? Do we have meta understanding at this point? It may take you some time to formulate a question. In the process to formulate a question, a concept is understood. This happens a lot for myself. Okay, so when sometimes in a lecture myself, I would have a question about something, but in the process of formulating a question to ask the professor, I would understand it already. Because your brain, by recasting something into a question, I think it exercises your brain, a different part of your mind, and through that, you will actually start to get a better understanding of the material. But the first thing is important. You have to stop me first, because otherwise I will keep talking, right? And you'll be missing the other stuff as you formulate your question. It's much better to stop me and go like, okay, I have a question. Okay, pause. I stopped. So take your time to formulate your question. Don't feel pressured, because the fact that you have a question means many other students in this class will probably have a question as well. Okay, so nobody's going to say, "Oh man, come on, move on." It's we need to get through the other material. Most students are going to thank you and say, "Thank goodness somebody is stopping tag." Okay, so go ahead and stop me. Just say, okay, I got a question, and take your time to formulate the question. If you study, try your best to do your part. Don't worry about the rest of the class or what you think they might think of you. Take your time. Okay, that's the most important part. The fact is, out of this class, maybe of 40 students or so on, after this class, you might not see the rest of the class again. Okay, so if you think, I'm going to embarrass myself, if I keep asking questions, there's no consequence to it. They're not grading you. The rest of the class is not grading you in any way. So don't worry, even if someone explicitly said, you're slow, come on, move on. Just ignore that. Okay? Utilize my office hours. Okay, if you find there's a concept already discussed in class or something that will be discussed in class, but you're not quite getting it, come to my office hours. That is a really good way to use resources available to you, because it's a one-to-one time, and the pressure to move on or to formulate a question really fast is completely gone, because most of the time I don't have anyone waiting for me in my office hours. In this class, you will be doing a lot of problem solving. Programming is all about problem solving. What is the title of cisp310, which is the first programming class?
Algorithm problem solving.
Exactly, algorithm design and problem solving. Okay, so every program, when you write code, it is all about problem solving. So after a concept is understood, the ultimate test is to apply the concept to solve problems. Because if the concept cannot be applied, it means it's not really useful. Okay, you've got to be able to use that to solve problems. And problem solving is the forming of a chain of links, and each link is basically a step that takes you from one thing to another thing. Okay, so if you think about problem solving, it's basically just a long chain, and you're connecting all smaller steps together. Okay, in that way, it is almost like Legos. You have Lego pieces, okay, and you want to make something out of these Lego pieces. Now, Lego pieces are extremely versatile, but if you look at each piece, it's pretty simple, right? So I'm just going to give you a picture here for those of you who do not know what a Lego piece looks like. Okay, it's just a piece of plastic, usually rectangular in shape, but they do have some interesting shapes as well. And they have pegs on one side, and then they have like holes, and other things on the other side, so they can stack up. Okay, but they can stack up like straight up, offset, and in many other ways. So using very basic Lego blocks, you can make something that is really interesting out of it. But when you look at each piece, it's very simple. Problem solving is the same thing. Understanding means, okay, I can see how each piece works. But problem solving is to say, now that I understand what each piece looks like and how I can use each piece, how do I make a car out of Lego blocks? How do I make a tank out of Lego blocks? How do I make something out of Lego blocks? That is problem solving. How do you make use of the individual pieces to make a bigger piece? So practice becomes important because it's how do you know how you can hook up these individual pieces? You have to practice. Okay, busy work is not going to be sufficient. In this class, I don't do a whole lot of busy work, but there are a lot of homework assignments designed to let you exercise the individual concepts so that you can have a better understanding of those concepts. Just yesterday, I was in cisp310. And I mentioned something in class I think some student probably did not take very well. I said the homework assignments are designed to be challenging, okay? Because they're designed to make people work, okay, to understand the concepts. And I said something like this. If you don't get stumped at least once in your homework assignments, I am not doing my job. They are supposed to stump people, okay? They're supposed to be the brain teasers, okay? And it's the same way, and I used a different analogy as well. Okay, let's say a cyclist is to train for a tournament, okay? Do you think this cyclist is going to train by coasting downhill?
No.
With both legs up and just go like, I'm practicing steering? Or do you think that person will probably benefit more from going uphill, downhill, level, and so on? Okay, same thing with programming. Okay, if the homework assignments are so easy that every single homework assignment only requires like 2 minutes, it's mostly just busy work, it's not going to be that useful. Okay. All right, moving on. Independence. Now, if I expect 100% absolute independence from all of you, there's no need for me to be here. Right? Because if you guys can learn 100% independently, you can just get a book and learn from the book. So I'm not talking about 100% independence. I'm talking about independent from other students when you're doing your homework assignment. That is what I'm talking about. So this is not really an honesty policy thing because you can probably someone can ask other students for help and still not be considered dishonest or cheating. That's okay. The question is how often and how much should you ask for help from another student? That really is the question. When do you give up and say, okay, I'm totally stumped, I'm not going anywhere with this? Okay, the first thing is you have to make sure that you have a good understanding of the concepts. We just talked about this, okay? If there's something that you don't understand or you think I may not be understanding it correctly, get that cleared away first. How do you do that? Well, with programming classes, it's easy. I wouldn't do this with a bomb disarming class. Let me try that, right? Okay. But with a programming class, you can do it. Okay. So in this class, there will be cases like, okay, this is a particular addressing mode for an operand. I think this is how it works, okay? But how do you confirm your understanding is correct? You design a small experiment, okay? And you say, if my understanding is correct, this program should behave this way. But if my understanding is incorrect, okay, you have alternate hypotheses. If the alternate hypotheses were right, then it will give you a different outcome. And what do? You spend about 5 minutes, write a 7-line program just to test that concept. If it works out the way you think it is, you have confirmation that you are probably right, okay? But if it doesn't work the way you think it should be working, then you have confirmation that, oops, I think I got it wrong. Let me read the material again and see if I can understand it in a different way. Okay? Perseverance is important as well. Don't give up too quickly. Now, this is kind of subjective. How quickly is kind of subjective. And when I was a student, 2 days was my limit. If I cannot solve a problem or have a good understanding and feel comfortable with something, then I'll go ask someone. Not 2 hours, not 2 minutes. But that's up to you, okay? This is entirely subjective. Some people think, oh man, 2 seconds is too long already. I'm stumped. I have been stumped for 2 seconds. I need to ask someone for help. And remember, in this class, doing the homework assignment is studying. Okay, that really is how I plan to plan for you guys to study. Sometimes you also need to have a flexible and open mindset. In other words, if one particular understanding or one particular way of looking at something is not working, try alternatives. Okay, what have I been missing? Okay, what is the other way to interpret this sentence? And so on, okay? All right, click. Grading standard. This is a long one too, okay? I'm not gonna explain the whole thing. What I'll do is I'm gonna explain what is an A, what is a B, what is a C, what is a D, and what is an F. And I'll also start with asking you guys, what is the worst possible grade out of these 5? A, B, C, D, F. Which one is the worst possible grade that somebody can get in the long run? Not in the short run, but in the long run.
C.
C, exactly. A C is the worst possible grade because if I'm graduating or if I'm getting out of a class with a C, so let's say I'm trying to take an art class, which I really suck at, right? And I get a C out of that class. It gives me just enough grade to move on to the next class, which is advanced or intermediate art appreciation. But what is a C implying about my understanding of art appreciation?
Marginal understanding.
Marginal, exactly. It is marginal. Okay, it means the professor does not want to see me again in that class. Okay, but I get bumped up to the next class. So do you think I'll be successful in the next class? Advanced or intermediate, art appreciation? Not likely, right? So I'm going to struggle through the next class again, and then the next class, and then the next class. Does that make any sense? All right. So a C is the worst possible grade, but what about a D and an F? I mean, doesn't that really suck? Not really, okay? I do not judge people, and neither should you do it to yourself, okay? Don't judge yourself if you get a low grade, okay? Things happen, okay? There are reasons that people may be getting a low grade, okay? So don't judge yourself. A D is just a D, an F is just an F, okay? Nothing more, nothing less. But with a D or an F, you can take the class again. Up to 3 times, okay? I have to kind of make sure that people understand you can take a class up to 3 times. But the second time you take a class, you get a better understanding of the material. Okay? I can tell you another story. This is actually real. My sister was an A student in high school. Okay, doesn't matter which subject. She was just an A student. All her life. She's not like me. I struggle through elementary school, middle school, and high school. Okay, I'm always at the bottom of my class. she always aced everything. She went to Berkeley. She took OChem, organic chemistry. She got her first D ever in her entire life. It crushed her. She went home, cried for a whole week. Okay? And then she took the class again. My wife took organic chemistry 3 times. She passed the 3rd time, but she told me by the time she took it the 3rd time, she really got the material. She understood the material. Okay? So it happens. Okay? A grade is just measuring whether you're ready to move on to the next class or not. It is not a judgment on your personality or anything else. It really is just, well, are you ready to move on to the next class? Is that okay? I'm not saying this to mentally prepare half the class to fail this class. Okay? I'm just mentioning this because I just want people to look at your grade in a slightly different way, than, oh, okay, I really suck at this. No, maybe you're taking too many classes or other things happened, okay, in the semester, okay? All right, so now we move on to the actual meaning. In the class, what is an F? An F means no work is turned in, or whatever is turned in resemble one from a person who has not taken this class or has no knowledge of the material of this class. That's basically what an F is. Okay, there's no demonstration of any understanding or any knowledge of what is taught in this class. A D means something is turned in. It does not meet all the core criteria of the assessment. In other words, I'm looking for something specifically, as the core, as the most important piece, and that's missing from the submission. The core criterion is one that is essential, fundamental, or foundational. Okay, it is really, really important. What is a C? Well, something is turned in, it meets all the core requirements, but no more than that. Okay, it's just adequate, sufficient. B means something is turned in, it meets all the core criteria and some but not all of the advanced criteria of the assessment. An advanced criteria is one that involves abstract thinking, attention to detail, troubleshooting, independent thinking, deduction, creativity, synthesis of advanced concepts, and so on. So it's a step above the core concepts or the core stuff that I'm looking for. And A is just, excellent. Okay, it's just unbeatable. I cannot find a way to improve it. Okay. So as a result, I don't even bother with the 60% is a D and so on. I just do a straight scale. Okay. So the boundaries of D, C, B, and A are 12.5, 37.5, 62.5, and 87.5%. Are there any questions about how I assign letter grades based on score? Doesn't that mean it's easy to pass this class with a good grade? I'm not going to answer that question. You guys can ask around, but I'm not going to answer that question. Assessment activities, this is a typical thing that I do. 20% of your grade will come from homework assignments, so that's only 1/5 of your grade. There will be 3 exams. The first exam, which is about 1/3 through the semester, is 20% of your final grade. The second exam, which is about 2/3 through the semester, is 20% of your final grade, and the final exam itself is 40% of your final grade. So I'm not sure about how your other classes distribute the percentages, but I feel that this way it works fairly well. Okay, it gives people a chance to recover. If they kind of flunk one of the exams, there are 2 more to make up for that. It also makes it possible for someone to be doing fairly well with homework assignments the first and the second exam, but the final exam, because of sickness or some other reason, cannot focus and get a relatively low grade. That person will still be getting out of this class with a C or a B depending on how well the first or the second exams were. All right, moving on. This is a tentative schedule of this class. Okay, so we are obviously missing the mark already because we are supposed to start to talk about all this stuff today. Are there any questions about the syllabus? So what you need to do is to participate in the activity. Make sure that you click the right choice for each one, and then click next. Okay, and submit all and finish. If you misclick one, don't worry. I'm not going to drop you. You just have to take the assessment again. So in this case, I think I got 100%. Let me see. Does it say finish review? Okay, so now let me fix the other window so I can actually get into the class. Yep.
You mentioned open book, open notes.
Oh, right. Yes. Let me fix this and then I'll talk about that. Have you guys seen a syllabus this long?
No.
No. Well, I think with BCS, all classes are now starting to have a syllabi this long. It's a requirement. We have to spell out everything. Okay, so now if I switch back to the student view and just go back to the main part, I should see the second one open up. Yep. So that data and number representation is now available to me. You just click it, and you will see some activities. Okay, these are homework assignments, and the other ones are just HTML documents. So what you need to do, this is your reading assignment. Okay, so your reading assignment is to go through the first topic and read all the material. The labs are not open yet, but I think you can view it. You just there's no way to turn it in. Yeah, you can still view it. You just cannot turn it in. Anything. I'm not going to assign the assignments yet because we haven't really talked about the concepts. And we got about 15 minutes to talk about the concepts. So what I'll do today is I'm going to use those 15 minutes to talk about the concepts, and I'll use a portion of the lab time to also talk about some of the concepts because we lost some time due to the syllabus. And that part will be recorded as well. Yep.
Is there a textbook for this class?
There's no textbook for this class. All the materials are already on Moodle, so basically you just sequentially read through the material, and that's how this class goes. All right, so we'll get straight right into the main topic of this class. Okay, we'll start really low level for this class. Okay, and all of this stuff is available to you already. So if it is written on the whiteboard, you don't have to write anything down. Okay, it is the stuff that I mentioned, and you suddenly go like, oh, okay, I make the connection that you have to write down. Okay, something that you think about, that cannot be recorded by the video. That is something that you have to write down for your notes. Okay. What is that? I think that's a euro, right? That's a euro coin. Okay. What is the other thing sitting next to it? It's a vacuum tube. Okay, which is kind of like a light bulb, has a filament, it heats up. So we'll go ahead and take a look at the vacuum tubes first. Vacuum tubes were used in the 1920s. They are the main components of a computer called Colossus, as well as the ENIAC. Okay, what is the Colossus? What is the significance of the Colossus in the history of computer science? Sorry? It's the first digital computer. What was it used for? Why? Once again, we get back to the why. Why did we even have Colossus?
Was it for code breaking?
For code breaking, exactly. Okay, Alan Turing. Okay, how many people watched that movie? Imitation Game, right? And why did they name that movie The Imitation Game? The Turing test, exactly. I have seen people wear T-shirt, with a sentence saying "I failed the Turing test." And those people, wear that T-shirt, with pride. Okay. So the next one that came along were transistors. Transistors were first used in 1953. So you can see the 1920s, and then the next one up is 1953. So in 1953, we have the first computer that used transistors as its components. How many years passed? 30-something years, about 3 decades, right? 3 decades from now, what will be the version of Android?
iOS.
We don't even know 3 months from today, right? Okay, 3 months from today, what will be the new feature in Android or iOS? We don't know, because things are happening so quickly now. But it took 30 years to change from vacuum tubes to transistors. Okay. And transistors are much smaller, okay, but they are still discrete transistors. In other words, each package, each thing that you put onto a circuit board is one single transistor. They are smaller than vacuum tubes. They do not consume as much electricity, but nonetheless, they're not very small either. Eventually, it was practical to pack many transistors onto one single package, and we call that integrated circuit, or IC, or chip. And it was not until 1963 that we have the first computer making use of ICs as the main component. So that only took 10 years. Took 30 years to go from vacuum tubes to transistors. But after that, it only takes 10 years to go from individual discrete transistors to ICs. Do you see the shortening of the gap of revolutionary changes in technology? Okay. And I show a little graph here. I know it's really fuzzy. It's Moore's law. Okay, it's based on Moore's law. The horizontal axis is time, and it is linear. Okay, so it's just linear. 10 years, 10 years, 10 years, 10 years. The vertical axis is how many transistors can be packed into a certain area. I don't know exactly what the area is, but it's just the area. But it's not linear. 2,300, 10,000, 100,000, 1 million, 10 million, 100 million, a billion, and so on. It's a log scale. Okay? And you can see, what about this line here? The individual dots are landmark computers throughout time. And they plot it based on when did we have that computer invented, and what is the count of transistors in that computer. Okay? So what is this graph telling you? It's an exponential growth. Okay? In fact, I would say it's super exponential because we have some dots out here that is not even following the line. Okay, so it's somewhat super exponential. So that means we are packing more and more transistors into computers, and it's growing at an exponential rate. Moore's law states that every 18 months we can pack twice as many transistors onto an IC. That's a lot. Okay, you might think 18 months, that's a long time. Well, in 3 years, there are 2 18 months. In 6 years, there are 4 18 months. So in 6 years, you will have 4 times as many transistors as 6 years ago in the chip. Sorry?
Technically, isn't that 8 times?
No, it's actually 16. Sorry, I got my math wrong because it's 2 to the power of 4. Okay, 16 times. Okay, I stand corrected. That's a lot. Give it another 18 months, it's 32 times. Another 18 months, 64 times. So during your career as a computer science person, okay, so let's say you have a career length of, I don't know, let's just say 18 years, okay? How many 18 months do we have in 18 years? 12, okay? And how much do you think, comparing the first computer that you use when you enter the industry, as opposed to the last computer you use when you exit, when you retire from the industry, what is the growth? What is the increase of transistor count? 2 to the power of 12, which is
4096.
4096. Okay? And the density of transistors often correlates with the speed of a computer. Okay? That's basically what we are looking at. Yep, go ahead.
Are we going to run against the barrier?
Well, that's what they thought many years ago. Okay, I remember when I went to graduate school in about 1989, 1990 or so, they thought they hit the limit already at that time. That was what, 25 years ago, right? So they were getting down to almost a micron, which is 1,000 nanometer. Okay, so they thought they hit the limit when they were making transistors that is the size that has a size of 1,000 nanometers, and they thought the device physics would not allow transistors to go any smaller. What is the current generation of i7s? What is the transistor size of a current generation i7 processor?
22.
22, and I think they're moving on to 18 and 19, 18 or 17. Okay, so we saw a 50 times reduction of transistor size over 25 years. So every single time they thought they hit a limit, Intel found a way to get around it. So I'm not saying that this can go on indefinitely. I'm just saying, at this point we have not hit that limit yet, which is amazing, which is really amazing. There's nothing like this in any other type of technology. Look at automotive technology. Look at a Model T. Okay, compare a Model T with a brand spanking new Camaro. You will say, well, that's a big change. But are we looking at the same kind of change as computing equipment, as computing technology? When did the Model T came out? When did it come out? 1920s, 30s? Are there any car buffs here? No? I'm gonna look it up. Okay, because I want to contrast, the technology change of different technologies. Okay, Model T, okay, I just need to know the time, 1927. And
1908.
08? Okay, fine, we'll use 08. Even better. Okay, so how many years have passed? Man, it's a century, right? We'll just call it 100 years. Okay. What do you think is the horsepower of the original Model T? It had 20 horsepower. Okay? You look at 20 horsepower and go like, my moped has more than that, right? And you look at a modern day, Camaro, okay? So let's just say somebody bought the top end, Camaro off the lot of a dealership. How much horsepower are we talking about?
465.
465, call it 500. What is the increase over a century?
25 times.
25 times, which sounds pretty good, right? 25x. Okay, great. Now we look at computers. So we'll look up the Colossus. I know I had a typo here. No, I was actually right. I don't know whether they have a computation clock rate. Well, it used paper, okay, as a component, so it cannot be too fast. The tape reader was tested up to 97 characters per second, or 53 miles per hour. It doesn't quite say what is the processing speed of these things. So what we'll do instead is we'll look at modern day computers, okay, the x86, the 8086 processor. When did that come out? Intel 8086, which is the first processor used in IBM PC computers. All right, so that's the chip. Okay, so we'll say, when is the time again?
76.
76, okay, 1976. We have 8-bit processor, okay, so it's an 8-bit processor operating at about 4.7 megahertz, okay, single core. Without pipelining and all kinds of cool stuff like that. Okay, so effectively, the actual number of instructions they can execute per second is about 4.7 divided by 3 or 4. That would be a more realistic estimate of number of instructions that you can execute per second. So we are looking at maybe 1 MIPS or so. Million instructions per second. Okay? So we'll fast forward to today. 2015, let's say you have a middle of the line i5 processor. What is the clock rate of an i5 processor? Just midline, not looking for extreme stuff. 3 gigahertz-ish, okay? So we'll call it 3. How many cores do we have with a middle of the line i5 processor? 4 cores, okay? And what is the width of each core? It's classified as a 64-bit processor, okay? So it's 64-bit, okay? But because of pipelining and having multiple ALUs per core, we actually get to pretty much, the clock speed is actually the MIPS rating. Sometimes it's actually faster, okay? It can actually perform multiple calculations per clock because there are multiple ALUs. We'll talk about all of that stuff later. So we're talking about 3 MIPS here. No, GIPS. Or 3,000 MIPS. All right. So, what is the increase of speed? 1 versus 3,000. 1 core versus 4, right? And if you look into the width of each operation, the 8086 is kind of like between 8 and 12 because the data path is 8, but the internal calculation path is 16. So we go from 16 to 64, which is by 4. So the increase is by 4 times. But this is not the entire story because the cache was not available in this processor. So every single operation, it has to go all the way out to memory to get the next instruction and so on. So caching can probably be speeded up by another factor of 2 or 3 easily. Okay, so we'll just say 2 because of caching. So what is this number? 3 times 4 times 4 is 48. 48 times 2 is 96. So we're looking at maybe around 100,000. And how much time has passed? From 76 to 2015.
39.
39, we'll call it 40 years. So with computers, in 40 years, we are looking at a 100,000 times of speed increase. And I think this number is conservative, okay? In automotive stuff, cars, internal combustion engine, we are looking at 25 times. And that's over an entire century, not 40 years. Are you guys kind of seeing the picture here? How this technology is fundamentally different from automotive technology or jet engine technology or anything like that. In other words, if we are still stuck with biplanes, we'll still be making drones using biplanes. Because these days, you can easily put a computer with GPS onto a quadcopter, right? That's why computer is a revolutionary type of technology. It's not just changing one little thing at a time, it makes other things possible. Are we doing okay so far with all this stuff? Okay. So in World War II, okay, let's say not even World War II, let's say in Cold War, okay, in the Cold War, if someone suggests to a general and say, I think we need to have autonomous drones, What do you think the general is going to respond? How is the general going to respond in 1965? Somebody approaches the Air Force, commander, and say, we need to have, autonomous, airplanes.
No.
Too expensive to rearm.
No, the general will say, well, I asked the computer science people, we don't have an aircraft big enough to fit a computer. That's going to be the answer. You can load up a whole B-52 with computer stuff, and it would still not have enough processing power to automate, any type of flight. Well, any type of flights that we know of today. I mean, they had guidance stuff and whatnot, but not the same kind of computing power that we have. Okay, how much processing power do you have in your pocket right now?
A lot.
Compared to the Colossus. Yep. So I'm going to take a pause here. I will stop the recording, and then when we get to the lab, I will do a little bit more lecturing, and then I will talk about how to set up an environment for your homework assignments.